Let us understand today what is mutual information. So consider two discrete random variables, or we can say sources, capital X and Y, with possible outcomes xi equal to xi and yk, where I tends from 1 to up to m and k tends from 1 to up to small n. So this is a random variable or source x, which is giving small x1 x2 up to xm, and capital Y, which is given y1 to yn. So for all these we are saying it is xi, and for all this we are saying it is yk. So what is mutual information? If the event y equal to yk has happened, or yk can be y1, y2, yn. Now this event, what this event gives information about x equal to xi. Xi can be x1, x2, xm. For example, we can say that suppose there are two friends, Omkar and Krishna, and if Omkar comes to the school, so what is the information it is giving about that Krishna will also come to the school? So it is like that. That is mutual information. That means presence of Omkar, how much it will give the information that what are the chances that Krishna will definitely come to the school. So that is mutual information. What is self information? Self information is like what is the information what is the information transmitted when y equal to yk event occurs. That is self information. What is suppose here also we can say if x equal to xi, then what is the self information? That we know that it is my log 2 of 1 by xi. Here self information is log 2 of 1 by yk. But mutual information is if this event occurs, what this event gives information about x equal to xi. So mutual information between xi and yk is the amount of information event y equal to yk provides about the event x equal to xi. It is given as, this is the mathematical formula, ixi comma yk, or it is also represented as ixi semicolon yk, that is equal to log 2 of p of conditional probability xi given yk divided by pxi. Okay, so this you have to remember. After that, let us see what are the properties of mutual information. So ixi semicolon yk is equal to iyk semicolon xi. That means mutual information is symmetric. Now let us see the proof of it. So ixi comma semicolon yk is equal to log 2 of p of xi given yk divided by pxi. In next step, we are going to multiply it with pyk and divide it with pyk. So there will not be any change in this expression, because we are dividing as well as multiplying with pyk. Now this is nothing but the joint probability pxi comma yk or semicolon yk divided by pxi into pyk. Now if you take this one, pxi comma semicolon yk divided by pxi, so this part is nothing but pyk given xi. This we have already seen the probability formulas. So this part is nothing but pyk given xi, not divided by pyk given xi divided by pyk. So now this is nothing but pyk semicolon xi. For example here ixi semicolon yk is nothing but, here you are getting pxi by yk divided by pxi. So if it is pyk by xi divided by pyk, okay, here this one, then that is nothing but what, pi yk by yk semicolon xi. That means you are getting ixi semicolon yk is iyk semicolon xi. That is mutual information is symmetric. That means occurrence of the event xi, whatever the information it provides, occurrence of the event yk, whatever the information it provides about xi, same is the case, occurrence of xi will provide for the occurrence of yk. So here the same is written. Next one is, if xi and yk are statistically independent, then mutual information is equal to 0. So in this case, if Omkar and Krishna are not the friends, or they are in different schools, then whether Omkar is present in the school or not present will not give any information about the presence of Krishna. So Ixi semicolon yk is equal to, let us see the proof. Ixi semicolon yk is equal to log 2 of pxi given yk divided by pxi. Now xi and yk are independent, then pxi given yk is pxi, because this probability does not depend on the yk, so it has no concern with yk. So pxi given yk is pxi. Now if you put here pxi by pxi, that is log 1 is equal to 0. So mutual information of statistically independent event is 0, and that is obvious, na? If there is no dependence, then they will not share the common information. So when y equal to yk uniquely determines the occurrence of x equal to xi, then mutual information becomes self-information. So when y equal to yk uniquely determines occurrence of x equal to xi, then mutual information becomes self-information. That means if Omkar and Krishna are in the same school, and if Omkar comes to the school, Krishna definitely come to the school, and if on that day there is an exam, then there are definite chances that Krishna will definitely come to the school. So here we can say that p of xi given yk is 1. That probability is 100%. That yk will definitely say all information about xi. So pxi given yk is equal to 1. That probability is 1. Damn sure or 100% sure that yk will definitely say is related or is uniquely determines the occurrence of xi. Then at that time it will become 1. Then it will 1 by p of xi. That means this is nothing but self-information of xi. Self-information of xi. That means then the game is dependent on xi only. Now it is whether xi will come or not, that is totally dependent on probability of xi. So for dependent events, for uniquely or closely dependent events, or we can say that the dependency is 100%, at that time mutual information becomes self-information. So these are the 3 properties of the mutual information that we have discussed in this channel, in this video. So I hope you understood the concept. So if you like this video, give a thumbs up to this video. Also subscribe to the channel for more such videos on this channel. Thank you.